Hello everyone, Mr. Crone here. I'm going to do a quick lesson on converting from binary to decimal and decimal to binary, or base 2 to base 10 and then base 10 back to base 2. Here's our first number. We have 101 base 2 and we want to find the equivalent in base 10. I went ahead and wrote out the bases for us in base 2. Remember, it just starts at 1, then 1 times 2 gives us 2, 2 times 2 gives us 4. We could keep going on with those bases, but I stopped because our number is only 3 numbers long. So now, the hard work has been done for us. Next thing we need to do is just for each base that has a 1 above it, we want to add that up. So we're going to take 4 plus 1. We skip the 2 since there's a 0 above the 2, and we can add those up. That will give us 5. So the final thing that you could write is 5 base 10 is equal to 101 base 2. And that's the end of that problem. Let's do one more example of this. So for example 2, we'll make it a little bit more difficult. Let's do 11010, and this is going to be base 2. We want to find the equivalent in base 10. I just went ahead and wrote out the bases for us, and then we'll just do the same process that we did last time. We want to write up and add each base that has a 1 above it. So we're going to do 16 plus 8 plus, now we'll skip the 4 since there's a 0 above it, plus 2 plus, and then that's really it. 1 has a 0 above it, so we don't add the 1. And now we can go ahead and add 16 plus 8 is 24, plus 2 is 26. And now we're almost finished. Let's just write it up nice. So 11010 base 2 is equal to 26 base 10. And that's the end of problem number 2. Alright, so we just went from binary to decimal. Now I'd like to go the opposite way, from decimal to binary. I'll give you a standard base 10 number. We have to convert it to a binary number. So for example number 3, I'd like to convert number 7 base 10 into something base 2. First thing we're going to do is just write out our base 2 bases, or our binary bases. So 1, 2, and we're going to keep going until we get greater than the number that we're trying to convert. We're trying to convert 7, we just hit 8, that means that we're finished. Now we can actually delete that 8 because we aren't going to be able to use it. Next thing we're going to do is we're going to go to this next biggest base right here, and we're going to put a 1 above it because we can take 4 out of 7. So let's go ahead and go do that. 7 minus 4 is equal to 3. Every time you put a 1 above a number, you have to do a subtraction problem and update how many you have left. We're trying to convert the number 7. We just accounted for 4 out of the number 7. Well, now we need to account for the last 3. We go to the next base. We have 2. Can 2 be taken away from 3? Yes, yes it can. We put a 1 above that. Do our next subtraction problem. 3 minus 2 is equal to 1. We have 1 left. Fortunately, our last base is 1. We can put a 1 above our last base, do our last subtraction problem here. 1 minus 1 is equal to 0, and you have 0 left. If you reach the last base here and you still have something remaining, you did the problem wrong at some point and you need to go back and redo it. But the last thing that you could write here is just 7 base 10 is equivalent to 111 base 2. Alright, in example 4, the final problem I'll do in this video, we're going to convert 37 base 10, and we want to convert that to a binary number base 2. Start out with the same process as we did last time. We're just going to start writing bases until we get larger than the number we're trying to convert. So 1, 2, 4, 8, 16, 32. We'll have to do one more. That'll take us to 64. 64 is greater than 37, so we're not going to be able to use that guy. Next thing that we'll do is we will take away 32 from 37. Once we do that, we can go ahead and come down and start doing our subtraction problems. We can take 37 minus 32. That's going to give us 5 left. So we have 5 left that we have to account for. We go to the 16. Can 16 be taken away from 5? Well, it can, but it will be a negative number, so we're not going to do that. So no. We go to the 8. Can 8 be taken away from 5? No. Can 4 be taken away from 5? Yes, so we put a 1 above that guy, and then we come down here and do our next subtraction problem. So now we say 5 minus 4, that is going to give us 1 left. We go to the 2, can we take away 2 from 1? No, and then we want to use our last one, and we can do our last subtraction problem. 1 minus 1 is equal to 0. We have 0 left, that means we're correct, and now we can go ahead and just write out our final summary here. 37 base 10 is equal to 100,101 base 2.